All right, hey Honors Chemistry. So something I wanted to teach you today is how we could determine empirical formulas from laboratory data. And then eventually you'll be able to do calculations that are a bit more focused on giving you mass data. So just to remind you what an empirical formula is, an empirical formula is the simplest ratio of atoms in a compound. So for example, in something like if I had CH2O, this would be an empirical formula, and the simplest ratio would be 1C for every 2H for every 1O, as opposed to C4H8O4, which these numbers would not be the simplest ratio, this 4C to 8H to 4O. This would be simplified by a 1 to 2 to 1 ratio. And we call something like this a molecular formula. And we're going to do a couple of notes on that next time in class. But the difference between empirical formula and molecular formula is that the empirical formula is the simplest ratio of atoms. And typically the empirical formula is the one that is determined by data. Determined by experiment and data, which is what empirical really means. It's a Latin derivation or some sort of derivation of determined by data. All right, so let's look at this lab data that I retrieved from a group. So their mass of their empty beaker was 105.70 grams, and their mass of their zinc and their beaker before the reaction was 109.30 grams. When they added hydrochloric acid, they noticed that all of the zinc reacted. So we don't have to do any type of special math to figure out whatever zinc was left over. All of the zinc reacted. So I could figure out my mass of zinc using the mass of the empty beaker and the mass of the beaker and zinc. And then later on, they boiled off everything, the water and the excess hydrochloric acid or whatnot, and they got a mass of 113.09 grams. So now let's use this data and do some calculations here. So I'm going to put that on the side here. So in looking at this, I noticed that the difference in the mass between my beaker that's empty and the amount of zinc in the beaker is going to be my mass of zinc. So let me do those calculations. So over here, if I want my mass of zinc that reacted, it's going to be the mass of the zinc and the beaker minus the mass of the beaker, right? And in this reaction, I'm telling you that you're assuming that all of the zinc reacted. Most of us used a lot of zinc, and then since you used a lot of zinc, you had to figure out how much zinc reacted. For the type of calculations that we're going to do, and to simplify some of your calculations, we're just going to make the assumption that everything reacted to completion. So, my mass of my empty beaker was 105.7 grams. I'll put that over here, 105.70 grams. And my mass of my zinc in beaker was 109.30 grams. And I subtract these two. And again, my mass of my empty beaker was 105.70 grams, and the mass of the zinc and the beaker was 109.30 grams. And I'm telling you that all of the zinc reacted. So whatever zinc I had here, that zinc was carried out through the reaction. So if I do this math, I'll do 109.30 minus 105.70, and I get 3.60 grams of zinc reacted. And I've had a chance to ask a couple of groups, but we're trying to determine the empirical formula of some zinc chloride. And if you remember the reaction, zinc plus HCl yields H2 gas, that's what bubbled out, plus Zn, we don't know the formula, Cl, we don't know the formula. So this 3.60 grams of zinc that reacted, that's how much zinc we had to begin with. How much zinc should I have in my product then? And I've asked a couple of teams that question, and you should have answered it that, well, if I had 3.60 grams of zinc that reacted, that's how many grams of zinc should be in the zinc chloride, and that's because of conservation of matter. I'm not going to lose that zinc to anything else. The zinc's mass is not going to change. Matter cannot be created nor destroyed. So I'm going to have 3.60 grams of zinc in the zinc chloride. Okay? The next calculation would be if I want to just get my mass of zinc chloride. So I have, if I want my mass of zinc chloride, right? This data here is the mass of the zinc chloride in the beaker. This is after boiling. And as most of you remember in your lab, you had to boil off the excess water, excess liquid, excess any other aqueous stuff or liquid stuff that was in there. And you were left with a white, filmy, maybe creamy solid that was zinc chloride in the beaker. The best way to figure out the mass of just the zinc chloride would be taking the mass of the zinc chloride beaker and then subtracting it just from the mass of the empty beaker. So mass of the zinc chloride beaker and subtracting it from the mass of the beaker. And we already know that the mass of that beaker is not going to change. We're using the same beaker or whatever flask you use. That's going to be 105.70 grams. And it looks like the mass of the zinc chloride in the beaker was 113.09. So 113.09 grams. Okay? And so if I do this subtraction, I'm going to get my mass of zinc chloride. And I get 7.39 grams of zinc chloride. So trying to help you organize your lab data and calculations, making sure that you have all of this lab data. Now we have a mass of zinc and we have a mass of zinc chloride. So let me just write that down as kind of like a data table here. I have a mass of zinc that reacted. That's equal to 3.60 grams. And I have a mass of zinc chloride that formed. And that's 7.39 grams. And that 7.39 is this mass of my zinc chloride product. Now, remember, our question was, what is the ratio of zinc to chlorine in the zinc chloride? Right, we're trying to find the empirical formula. And we get that from lab data. So the empirical formula is this ratio. Well, I have my mass of zinc, and I have my mass of zinc chloride. So now I have to figure out what would be the best way for me to figure out how much chloride I have in here. Well, I already told you before that if I have 3.60 grams of zinc to begin with here, and it's fully reacted, I must have 3.60 grams of zinc in my product. Well, if I know the total mass of my zinc chloride product, and I know the mass of zinc that's in that zinc chloride, if I subtract these two, I will get the mass of chloride. So the mass of Cl is going to equal the mass of the ZnCl minus the mass of the Zn. Does that make sense? Right? So if I know that the mass of zinc and zinc chloride is 3.60, the only difference between these mass has got to be due to chlorine. So let me subtract these two. 7.39 grams minus 3.60 grams, and I get 3.79 grams of chlorine. And now I have a mass of chlorine in my product. So mass of chloride is equal to 3.79 grams. Right, so now these were some things that I asked you to calculate in your lab, and now I'm going to show you how we could use this data to figure out the empirical formula of the magnesium chloride. So, what can I do? I mentioned in class that it's difficult to compare masses, right? It's difficult to compare masses of two elements. We could get a ratio of the mass of the elements. I could do that right now. Let's do mass ratio of chlorine to zinc. And so all I'll do is we always do bigger over smaller. So it'll be 3.79 grams of chlorine for every 3.60 grams of zinc. And if I do that mass ratio, I get 1.05 grams of Cl for every 1 gram of zinc. Okay? And I notice that it's almost 1-to-1 in mass ratio. However, why can't we compare masses? Cannot compare masses because, think about that. Why can't I compare the mass of chlorine to the mass of zinc? Looking at this mass ratio, it looks like my mass is 1-to-1. So does that mean I have 1 chlorine for every 1 zinc if the mass ratio is 1-to-1? No, because the elements have different masses. Dalton once used the mass ratio to figure out the empirical formula, and we did that. We did the Avogadro's hypothesis and Dalton's law, and we looked at the mass ratio, and we were able to figure out how much more of one element is in a compound than another. But if I just want to compare two elements in a compound, using the masses is not going to be the best way to do this, because every element has a different molar mass, as we saw. So what I'm going to have to do is I know that 1 mole is equal to 6.022 times 10 to the 23rd atoms. So I know that if I have 1 mole of zinc, I will have 6.022 times 10 to the 23rd atoms of zinc. If I have 1 mole of chlorine, I know that that also means I have 6.022 times 10 to the 23rd atoms of chlorine. This mole business we can use to compare, because a mole of zinc is the same number of atoms in a mole of chlorine. Now the masses are not included in here, right? But how can I figure out how many moles of zinc and how many moles of chlorine I have? Moles of zinc or moles of chlorine. Well, we spent a lot of practice and time being able to go from grams to moles. And what we do is, to go from grams to moles, we take our grams and we multiply by 1 mole over the molar mass in grams, and we're going to end up with our moles. And where do I get the molar mass of zinc or chlorine? From the periodic table. Okay, so we cannot compare two elements by mass. Dalton used to do that, but Dalton's a bit outdated. He was good at getting us to compare elements by masses, but we realized that not every element has the same mass. So that assumption didn't work for us. So now we're going to convert the grams of zinc that we have to moles of zinc. So just to remind us, we have a mass of zinc, which equals 3.60 grams of zinc. Let me convert that to moles. Just so you know, the molar mass of zinc, according to the periodic table, is, it should be like 65.39 grams per mole. Right, so 3.60 grams of zinc times. Now, remember how to do dimensional analysis. I want my grams on the bottom, and I want whatever I want on top, which is moles. So I know that there are 65.39 grams of zinc and 1 mole of zinc. And if I do this math, I should get 0.0550. 0.0550 moles of zinc. Okay? So now I have a moles of zinc. And I know that corresponds to a certain number of atoms of zinc. Let me do moles of chlorine now, or moles of chloride. By the way, the difference between chlorine and chloride is that Cl minus 1. Chlorine would just be Cl. So sometimes I go in between those two. I know that they're going to have the same mass. You'll eventually know that just because an atom is charged doesn't mean that its mass is going to be different. Electrons have a relatively small mass, so an ion is going to weigh the same as an atom. An ion of an element is going to weigh the same as an atom. So if I want my mass of chloride, I had before determined that the mass of chloride was 3.79 grams. And the molar mass, according to the periodic table of chlorine, 35.453. 453 grams per mole. Now I'm gonna convert that to moles, and this is good practice because on your next unit tests, and for this unit and for the rest of the semester, you're gonna have to know how to go to moles. So 3.79 grams of chlorine times, using dimensional analysis, 1 mole of chlorine goes on top. Trying to make sure that you can separate this, and 35.453 grams of chlorine goes on the bottom, because for every 1 mole of chlorine, I have 35.453 grams of chlorine. And if I do this math, remember, you multiply by the numerator, so 3.79 times 1. I'm going to write that here anyways. Multiply by the numerator. I've said this so many times in class, but I wanted to make sure it sticks. And then you divide by denominator. So I'm dividing by 35.453 grams. So if I do this math, I should get 0.1070 moles of chlorine. Okay? So now I have a mole. I'm going to write this down here. Now I have a moles of zinc, which equals 0.0550 moles. And I have a moles of chlorine, which equals a 0.1070 moles. And now I could use the moles to compare these two elements in the compound. And kind of just by looking at it, it looks like I have twice as much chlorine in this compound than zinc. This is what you're going to do with our next and last topic, is I'm going to convert whatever grams I've given to moles and then divide by the largest by the smallest, or divide by the smallest number to see how much bigger one is than the other. And we've done this with relative masses. So in order to get this empirical formula for the zinc chloride, right, I want to divide the largest by the smallest, or I want to see how much bigger moles of chlorine is than the moles of zinc in this compound. And if I do this math over 0.0550 moles of zinc, this tells me that I have 1.9456 moles of chlorine for every 1 mole of zinc, which basically, if I'm estimating, this is about 2 moles of chlorine for every 1 mole of zinc. So if I want to write a formula that has 1 mole of zinc and 2 moles of chlorine, that formula would be ZnCl2. Okay? So this would be the empirical formula. I compare the ratio, the moles, and the ratio of those moles, and I always divide by the smallest number of moles. What you'll see, what we'll do later is I could put those moles as like fake subscripts. So our moles of zinc was 0.0550. I'll put fake subscripts, and then Cl was 0.1070. 0.1070. I could make these fake subscripts, and we know that subscripts are supposed to be whole numbers, and I divide by the smallest number. Because I want to see how much larger one number is than the other. The smallest number is this zinc chloride. And so if I do, the smallest number is the moles of zinc. If I do this, this becomes 1, and this becomes Cl 1.95, which approximately comes 2. So then the formula would become Zn1Cl2, which we know that we don't write 1s as subscripts, so it would just be ZnCl2. In my next video, I'll do some examples where now we're just given mass data, and we could write and figure out the empirical formula from the data given to us. Okay, so I hope this video is helpful. It kind of wraps up your lab. You could use this as a guide for you to complete your lab calculations, and it goes with our next topic of determining empirical formulas from mass data.